Okay, so what if I told you that you could build an entire software product without a single human writing a single line of code? Sounds like sci-fi, right? Well, a team at OpenAI actually did it. They ran this wild experiment to see what happens when you flip the script, when you build a team not of engineers but for an AI agent.
Their goal was, just audacious. It became the core philosophy for the whole project. Build a real, shipping product with absolutely zero lines of manually written code. And I mean everything. The app logic, the tests, even the documentation. All of it had to come from their AI agent Codex. And the results? Just wow. They figured they built the whole thing in about a tenth of the time it would have normally taken. That is a staggering increase in speed, and it totally changes the game for how we think about building software.
So you've got to be wondering, how on earth did they pull this off? What breaks down? What actually works even better? And, what can the rest of us learn from this? This is that story.
All right, so here's how it started. The team literally created an empty Git repository. I'm talking no boilerplate, nothing to build on, just a totally blank slate. All they had was a high-level goal, and the Codex AI agent was the only one allowed to write code. The progress was, explosive is the right word for it. Get this, just 5 months after that first empty commit, the project blew up to 1 million lines of code. And we're not just talking about random code here. This was a real, functioning product that people inside the company were using every single day.
Okay, now let's talk about the scale here, because this is where it gets wild. You had a tiny team, just 3 human engineers, overseeing the creation of that 1 million lines of code. They merged something like 1,500 pull requests. If you do the math, that's about 3.5 PRs per engineer every single day. That pace is it's almost unheard of.
So, with that kind of crazy throughput, something had to change, right? The job of the engineer, it just wasn't about writing code anymore. It completely shifted. It became about designing the environment where the AI agent could actually succeed.
And this idea became their mantra. It's simple. Humans steer, agents execute. The human's job is to point the ship in the right direction, set that high-level goal. The agent's job is to do all the grunt work of actually rowing the boat. It's a real partnership, but the roles are crystal clear. Think about it. The old way? You're hunched over the keyboard, writing code, line by line, hunting for bugs, doing manual code reviews. The new way is all about thinking bigger. It's systems thinking. The engineers are building the scaffolding, the tools, the automated feedback loops, all the stuff that lets the agent do its job reliably. They're not workers on the assembly line anymore. They're the architects of the whole factory. And this leads to a huge mindset shift. A really fundamental one. When something broke, the normal instinct is to jump in and fix the code, right? But they couldn't do that. The only way forward was through the agent. So the question they had to ask themselves every single time was, okay, what's missing? What capability, what tool, what piece of info does the agent need to fix this on its own?
So, one of the first big problems they ran into was context. How do you give an AI all the information it needs for a huge, complex project? Their first idea seemed pretty logical. Just write a giant instruction manual. And, it was a total disaster.
And it failed for some really interesting reasons. For starters, a massive rulebook like that, it gets stale almost instantly. Then there's the context window problem. It just hogs all the agent's attention, leaving no room for the actual task it's supposed to be doing. And when you tell it everything is important, you're really telling it that nothing is. It all just turns into noise.
So they came up with this really elegant solution they called progressive disclosure. Basically, instead of handing the agent a giant encyclopedia, they gave it a table of contents. They started with a small, stable entry point that just points to where the deeper information is. They were teaching the agent how to look things up, instead of trying to cram everything into its head at once.
The repo itself basically became that table of contents. They had one short file that was the map, and it pointed to a really well-structured docs folder. And this folder, this library, had everything. Design docs, work plans, technical guides, all that stuff that usually gets lost in Slack threads or just lives in someone's head was now organized, versioned, and totally accessible to the AI team. Okay, so you've got this AI just cranking out code like there's no tomorrow. How do you stop the whole thing from turning into a giant chaotic mess? The answer, and this is kind of funny, was to add more rules, more constraints. These strict architectural rules became the guardrails that actually allowed the agent to go fast without crashing. And here's another mind-bending idea they had. The main reader of this code isn't a person. It's the next AI agent that's going to come along and change it. So the whole code base was optimized for an agent's legibility, for a machine to understand it, not for what some human engineer thinks looks nice. They enforced this with a really rigid, layered architecture. Think of it like this. Code can only depend on the layer below it. It can only move forward through these fixed layers. So, for example, the UI code could never talk directly to the database. And these weren't just suggestions. These rules were automatically enforced, which stopped the architecture from slowly falling apart over time.
And it's so important to get this. These constraints aren't there to slow things down. They're actually speed multipliers. They're what stops the project from rotting from the inside out. And that's what lets the agent keep up its incredible pace without just making a huge mess.
You know, with an AI writing so much code, you're bound to get some, well, AI slop. To fight this, they built a kind of automated garbage collection. They took human best practices and turned them into golden principles. Then they had other agents running in the background, constantly scanning the code for anything that broke those principles. When they found something, boom, they'd automatically open a PR to fix it. It's like having a robot army constantly fighting your technical debt for you.
So let's step back. What happens when your team has this insane level of throughput? A lot of the old rules of engineering, they just don't apply anymore. The whole economic equation of software development gets flipped completely upside down.
Think about it. In a normal project, fixing a bug is expensive, right? It takes time and effort. But when an AI agent can spit out a fix in just a few minutes, the cost of making a correction drops to almost nothing. The real expensive thing, the new bottleneck, becomes a human just sitting there waiting. It's actually cheaper to merge something that's mostly right and let the agent clean it up later than it is to wait for human perfection.
And where does this all lead? To a workflow that is genuinely autonomous. I mean, they got to a point where you could just give the agent a single prompt about a bug and it would do the whole dance. Reproduce the bug, write the fix, test the fix by literally clicking around in the app, open the PR, respond to comments, and merge its own change. It would only bother a human if it got really stuck and needed actual judgment.
So if we're going to boil this whole incredible experiment down to one key takeaway, it's this. You still need a ton of discipline to build good software. That hasn't changed. But where you apply that discipline has moved. It's not about writing the perfect line of code anymore. It's about designing the perfect scaffolding, the perfect environment that lets an AI agent do its best work.
And that leaves us with a really fascinating question, doesn't it? If the hardest, most important work is now designing these complex environments and feedback loops for AI agents, does that mean the future of being a software engineer is actually being a systems architect? Are we all just becoming architects for our new AI coding partners?